Hey everyone, so this is lesson 2. We're going to go over some more material involving equivalent expressions. There is a trig toolbox that's listed in the schedule. I will update that to be a completed version. I would normally ask you to complete that in class based on the identities that we're going to talk about. But I will post a complete version for you in the schedule. But for now, we'll get started on this lesson. So the first question asks to find equivalent expressions for this trigonometric function. We can see we have a period, goes from, what's this? This is negative 5 pi over 4 to 3 pi over 4, so the period's still 2 pi. It still takes 2 pi to complete a cycle. So we have a standard, no stretch horizontally or compression. It is shifted a bit. If we look at a cosine function, we know we have to start at the top. So we have a cosine of x or theta. It's shifted left pi over 4, so plus pi over 4, and everything's shifted up 1. So we get a plus 1 at the end. We could write it as a cosine function. We could also write it as a sine function. Sine functions, I'll write a slightly different one, I guess, than the one in the completed lesson. Sine functions, we start at our axis, so that our axis is going through y equals 1, and we go up. So we can do sine theta, we're shifted 5 pi over 4 to the right, so negative 5 pi over 4 plus 1, again, because our axis is y equals 1. So then, because both these are the same function, they both show this graph, these functions have to be the same, so we have equivalent expressions. We have two pieces that are equal to each other. We can create an equation out of that. So that has to equal that. Number 2, write 3 equivalent expressions for sine of 7 pi over 8 using the related acute angle. So 7 pi over 8, that is just less than pi, so that's in this top left quadrant. That's 7 pi over 8 there. So this related acute angle is pi over 8. So we can use that. We know sine has to be positive in that quadrant, so sine of 7 pi over 8 has to be the same as sine of pi over 8. The next time sine is positive is back in this quadrant, so it's also equal to sine of pi over 8 plus 2 pi, so sine of 17 pi over 8, or sine of 23 pi over 8 if we add 2 pi to this. In the completed example, they look at if you go backwards to 9 pi, negative 9 pi over 8. Actually, sorry, they look at these two quadrants here. This is the negative, so this would be 2 pi plus pi over 8, sine of 9 pi over 8, but that quadrant's negative, so this would equal the negative. And also this quadrant here is 2 pi minus pi over 8. So sine of 15 pi over 8. But again, that quadrant sign is negative, so we need to take the negative to get positive. So here we actually have 6 different 6 different terms that are equal to each other, we can easily create at least 3 equivalent expressions out of that. 3a, use the cofunction identity to state an equivalent expression for cos of pi over 2 minus theta. So pi over 2 minus theta would be this angle here. So we have our angle theta here. So pi over 2 minus theta is up till here. It's at angle alpha. So cos of this angle is our adjacent, like our x value, over our hypotenuse. Well, that x value, that's the same up here. For this angle theta, that's the opposite over the hypotenuse. That's going to be the same ratio. So cos of pi over 2 minus theta equals sine of theta. B, find an equivalent expression for cos of pi over 9. Well, similarly, cos of an angle theta is the same as sine of pi over 2 minus theta. So it has to be the same as sine of pi over 2 minus pi over 9. And we can find a common denominator. 18, 9 pi over 18 minus 2 pi over 18. It'll give us sine of 7 pi over 18. So cos of pi over 9 and sine of 7 pi over 18 have to be equivalent. C, sine of pi over 2 plus theta. Pi over 2 plus theta. Pi over 2 plus theta brings us to here. Because sine is positive in this quadrant and positive in this quadrant, we're going to have the same related acute angle as just sine of pi over 2 minus theta. So these angles are going to be the same. They have some symmetry across pi over 2. Part D, cotangent of pi over 5. From lesson 1, we talked about how the cofunction identity is, for cotangent, is tan of pi over 2 minus theta is the same as cotangent of theta. So again, we can do the same thing as part B. We can find a common denominator, so 5 pi over 10 minus 2 pi over 10 equals tan of 3 pi over 10 is the same as cotangent of pi over 5. Part E, tan of pi over 10, do very similar process. That has to be the same as cotangent of pi over 2 minus pi over 10. Common denominator, cotangent of 5 pi over 10 minus pi over 10 equals cotangent 5 pi minus pi, we get 4 pi over 10, and we can simplify and get 2 pi over 5. It's the same as tan of pi over 10. And we got one more, part F. Tan of pi over 2 plus theta. we can use similar logic as part C, except tan is negative in this quadrant. So it's going to equal negative tan of pi over 2 minus theta. Which, again, that's the same as negative cotangent of theta. So tan of pi over 2 plus theta is negative cotangent theta. A couple more equivalent expressions that may or may not be useful, but we'll move on for now. Question 4 talks about, it's a bunch of true and false questions, and if it's false, we need to correct it. So we'll look at 4a, cos of negative theta equals negative cos theta. Cos of negative theta is in the bottom right quadrant. That is where cos is positive. So this should be a positive cos theta. Cos of negative theta equals cos of theta. B, sine of theta plus 2 pi equals sine of theta. Guess we should have said that one was false. This one is true. Adding 2 pi, if that's our theta, 2 pi is always going to bring us back to the same spot. So adding or subtracting any multiple of 2 pi is always going to be equal to what it was before. C, tan of theta minus 3 pi equals negative tan of theta. Similar to how adding and subtracting 2 pi to sine and cos gives us the same answer, adding and subtracting any multiple of pi for tan gives us the same answer because the period of tan is pi. So this should be a positive tan theta. This should be false because the period of tan is pi. D, tan of pi minus theta equals tan of theta. Pi minus theta, we end up here. Tan is negative in this quadrant. This is the sine quadrant, so this should be a negative negative tan theta. This one says D again. It should be E. Sine of pi plus theta equals negative sine theta. Pi plus theta brings us to here. Sine is negative. This one's good. It's true. Using our cast rules. And last, it says E should be F. Cotangent pi over 2 plus theta equals tan of theta. Pi over 2 plus theta. Well, we just talked about this one on the last page. This is false because tan is negative in this quadrant, so it should be equal to negative tan theta. Number 5, write a simplified expression that is equivalent to each of the following. 5a, cos 13 pi over 12. 13 pi over 12, we're just past pi. We're in this quadrant on the left, bottom left. Cos is negative. We're pi over 12 past pi. So that's our related acute angle. So this equals negative cos pi over 12. We could also use a cofunction identity. Cos of 13 pi over 12 has to be equal to sine of pi over 2 minus 13 pi over 12. That cos of theta equals sine of pi over, cos of theta equals sine of pi over 2 minus theta. Always, always, always works, no matter how big our theta is. So we can again find a common denominator. 2 and 12. Need to multiply this by 6 and 6. And that'll give us sine of negative 7 pi over 12 is equal to cos of 13 pi over 12. And again, sine of a negative theta is equal to negative sine of that theta, because sine is an odd function. So we actually have three different equivalent expressions for this one. Part B, cos of pi plus theta, plus a, pi plus a, whatever a is, we're adding that. So it's equal to negative cos a. Cos is negative in this quadrant. C, sine of pi over 2 minus a over cos of pi minus a. Sine of pi over 2 minus a, that is one of our cofunction identities. That is equal to cos of a. And then we just, cos of pi minus a. If we're subtracting that a, cos is negative in this quadrant, so this is equal to negative cos a. That is all equal to negative 1. So this whole mess is equal to negative 1. And that's going to be our first kind of glimpse into trig identities and how they can be used. We can simplify complicated looking expressions into much simpler ones. D, tan of 5 pi over 4 over sine of 3 pi over 4. Tan of 5 pi over 4, tan's positive in the bottom left quadrant. Related acute angle would be pi over 4. Sine in the top left quadrant is also positive, and our related acute angle will be pi over 4. So now we have a tan over a sine of the same angle. Well, tan is just sine over cosine. And if we're dividing by sine of pi over 4, we're multiplying by the inverse. So 1 over sine pi over 4. Well, those sine pi over 4's cancel. We have a 1 over cos of pi over 4, which is equal to secant of pi over 4. So this term simplifies all the way down to secant pi over 4. Again, we have something kind of messy simplifying into something much nicer. And last but not least, cos of pi over 2 minus theta over cos of 2 pi minus theta. Cos of pi over 2 minus theta is one of our cofunction identities. I wrote that makes me, I'm not looking at the wrong one. Sorry. Cos of pi, yeah, it is one of our cofunction identities. that's equal to sine of theta. Then cos of 2 pi minus theta. So we're subtracting our theta. That's all the way around to here. Cos is positive in that quadrant. So this is equal to cos of theta. And sine over cos is just tan. So again, we have something that looks kind of ugly, simplifying down to something much simpler. This is what we're going to see more of in this unit of working with these trig identities. A trig identity is really what's going to be shown on that toolbox, and those tools that we can use to prove and simplify more complicated trig expressions and relate them to others. So that's the end of this lesson. Have a good day. Keep asking questions. It's been a little quiet, I guess, hearing from you, so I'm hoping all is well. I know trig is reasonable review from last year, just the addition of radians and now maybe some identity stuff, but keep up the good work and you'll hear from me again soon. Bye.